Alrighty, good morning everybody. We're going to be talking about ionic bonding today. So the question is, what is ionic bonding? Ionic bonding occurs between a positive ion, a metal cation, and a negative ion, a non-metal anion. So the key words here are positive ion, which is referring to a cation, and a negative ion, which is referring to an anion. And the negative ions or anions are typically non-metals, and the positive cations are typically metals because of where they're found on the periodic table. The opposite charges of the ions attract themselves to each other. So the negative charge on the anion is being attracted to the positive charge on the cation. And these opposite charges also cancel each other out and enable a compound, which is two elements bonded together, made up of ions or charged particles, to be neutrally charged or electrically neutral. So that was a lot of words there, so let's kind of break it down. So essentially what it's saying is that the opposite charges of the ions, so the negative charge of the anion and the positive charge of the cation, not only are they attracted to each other, but they bond in such a way that they cancel each other out. So if you have negativity, it gets canceled out by positivity, which means that a compound, which is two chemicals bonded together, or two elements bonded together, sometimes called a molecule, is actually neutrally charged. Even though it's made up of charged particles, it is actually neutrally charged or electrically neutral, so it has no charge. You don't have a compound that's an ion. It is a neutral compound. So how do ionic bonds form? The ionic bonds form when the positively charged cation is attracted to the negatively charged anion through the means of what we call electrostatic forces. These electrostatic forces then help to hold the ions together and make up those ionic bonds. So for example, here we have sodium and chlorine. Sodium has one electron in its outer valence shell, and chlorine has 7. Both of these elements are only one electron away from their full valence shell, or their full octet, as we sometimes call it, because typically you have 8 electrons in an outer shell. And so these are both only one away. Sodium is one away by losing an electron, and chlorine is one away by gaining an electron. So what typically happens is that this electron from the sodium will go in and the sodium will donate that electron to the chlorine. And then sodium, by losing one electron, gains its full octet, and chlorine, by gaining one electron, by gaining that same electron, gets its full octet. So if we look at it using electron configuration, sodium is a 1s2, 2s2, 2p6, 3s1, and chlorine is a 1s2, 2s2, 2p6, 3s2. There should be a 3p5 there as well. And so what's going to happen is that the 3s1 is going to donate all the way over to the chlorine and donate to the 3p5. Sorry about that animation, guys, but I've already restarted this a couple times, so I'm going to have to keep going with that. So again, you can see that this one is lacking one electron in its 3p shell to make a full valence. This one has one too many, and so it's going to donate this electron to the 3p5. So what we wind up having is sodium with one less electron and chlorine with one more electron. This means that the sodium is now positive. It's the cation because it lost an electron. Electrons are negatively charged, which means that when they lose an electron, when an atom loses an electron, since the electron is negatively charged, the ion is now less negative, which means that it is more positive, so it gets a plus charge, and that plus means that it lost one electron. Chlorine, however, is going to get a negative charge because it gained an electron. It gained negativity, and so it has more negative charge than it used to, so it's a chlorine minus. And now sodium is 1s2, 2s2, 2p6, which is its full valence shell, and chlorine is 1s2, 2s2, 2p6, 3s2, 3p6 instead of 5, so it's also got its full valence. So let's look at how it works. What if you had an aluminum? Aluminum has 3 valence electrons, and chlorine. The problem here is that we know that the charges need to balance out. And so I can't just take one aluminum and one chlorine and make it work, because If the aluminum donates 1 electron, then 1 chlorine is satisfied, but aluminum is not satisfied. It then still has 2 electrons to lose. So in order to make it work, we actually have to have 3 chlorine atoms, or 3 atoms that would be willing to accept an electron, and the 1 aluminum atom that is going to give and donate all 3 of its electrons. So for example, that electron is going to be donated to that chlorine, that electron will be donated to this chlorine, and that electron will be donated to this final chlorine. Which means that aluminum, since it lost 3 electrons, will be aluminum 3+, and chlorine, since it gained 1 electron, will be chlorine minus. So, the problem with balancing charges, though, is that we need to somehow make it work and explain how 3 pluses are balanced out by negatives. So the charges of the cations and anions need to balance out to create a neutral compound. So when we have an aluminum with 3 electrons and a chlorine with 1 minus, aluminum has 3 plus charges, it needs to lose 3 electrons, and chlorine has 1 minus charge, it only needs to gain 1 electron. So how do we make this work? And the way that we do this is by using something called chemical formula. And so scientists use chemical formula to show the types of elements and the number of each element in a compound. So as we saw 2 slides ago, since aluminum is a 3+, it needs to lose 3 electrons. It would require 3 chlorine minuses to donate 1 electron each to. So for the first example, we're going to actually go further back and look at sodium and chlorine. Only 1 atom of each element was needed to make up a neutral compound because sodium needed to lose 1, chlorine needed to gain 1. So its chemical formula would be NaCl, or table salt. 1 sodium, 1 chlorine. For the second example of aluminum and chlorine, 3 chlorines were needed for the aluminum to donate electrons to in order to make a neutral compound. So it becomes AlCl3, meaning that aluminum lost 3 electrons, and in order to lose all 3 of them, it required 3 chlorine atoms to do this. So we put this little 3 at the bottom next to the chlorine to signify that there were 3 chlorines for every 1 aluminum. And it's very important here that you note that that is a subscript letter. It is not a superscript. It is not the same size. It does not go above. It does not go in front. It is a small subscript number after the element that it's corresponding to. So we're going to work on practicing this and maybe even playing a few games to help us to put it all together. So I hope you guys had a wonderful weekend. Oh, nope, apparently we're not done. So that's how they bond together. We are going to practice that. The reason being is that it takes a lot of practice to get in. How are we going to name these? And so that's how we're going to do it, is that aluminum with 3 chlorines, AlCl3. So let's talk a little bit about ionic compounds. One of the things to note is that ionic bonds make ionic compounds, and they do so in the form of a crystal lattice. These lattices are composed of a set pattern and of order and symmetry. So they're very linear and very orderly and very strong. So this, for example, would be a sodium chloride. This is what we typically, scientists typically model atoms as, this is 1 sodium for every 1 chlorine. Or sorry, 1 chlorine for every 1 sodium. So that's what it looks like. You can see there's a lot of order, there's a lot of stability, and a lot of rigidity to there. Ionic compounds are then usually crystalline solids at room temperature and tend to be very stable, and so usually have high melting points. So again, because these are so rigid and linear and orderly and symmetrical, they're very stable at room temperature, they're solids at room temperature, and since they're so stable, it requires a lot of energy or temperature or heat to change them from a solid, so they have high melting points. That is now officially the end of the slideshow. I hope you guys had a great weekend.